And now we'll give the floor to the next presentation. And then after the 3 presentations, we'll open a discussion. So whilst we change the presentations, I'm going to introduce Professor Teodiano Freire Bastos. He's an associate lecturer at the University of Espírito Santo. He's a researcher in several research networks to do with engineering, some of them that we've already mentioned. In his presentation, well, in his career, he's stayed 2 years at the SIC, at the Robotics and Industrial Unit. He did a PhD at the University of Alcalá de Henares in 2005, and currently his experience focuses on electric engineering, focusing on measurement and control, with application to mobile robots, industrial robots, as assistive technologies, etc., etc. He has several patents. He has developed about 18 projects and processes, which are also waiting patent, and he's currently directing many theses, 4 PhD theses. And without further ado, I'm going to give Professor Teodiano the floor. Many thanks. I would also like to thank the ONCE Foundation for the invitation to be here.
I'm Teodiano Freire. I'm the coordinator of the Robotics and Rehabilitation Lab and also Assistance Technology at the University of Espírito Santo in Vitória, Brazil. And what I will be presenting are the most recent research which we had with children with severe movement-related disabilities, locomotive disabilities. This is not anything new. This research started a few years ago because we had lots of relations with a rehabilitation center for children and adults with a disability, and we realized that the children with severe locomotive disabilities are set aside in a wheelchair. Sometimes the carers and the parents come to see them, and they can never try to do something because the carers and the parents think that they are incapable of doing any activity. So a number of studies a few years back in Canada showed that the cognitive part in the children is still intact, so that they have the same capacity of the so-called normal child, and this gives them the possibility of interacting with their environment. So what we did is proposing our experience, contributing our experience so that they can use sensors that we have developed ourselves, which capture their movement, the different movements in their heads or one of the limbs, and we use electromyographic sensors to capture the muscular contraction so that they can, by moving a limb, to move a robot and achieve a contraction and to open and close a clasp or something like that. They can, in that way, they will be able to draw or paint, and they can grasp objects through this robot so that the parents can interact. And the very parents are surprised to see that because society and the family did not believe that the children would ever be able to do that. So the idea is telling you about our experience in the field. We've been 14 years working with assistance technology with people with disability, prostheses of upper limbs, myoelectric prostheses. We also work with sensors to help in the mobility of people who are blind, and we have tried to incorporate robotics Originally, I got training in robotics in Spain, and the idea was using whatever you use in robots, the control system, the sensor, and use that to help people with a disability. And 10 years ago, I started working with robots as a means of moving. Or we have developed a robotics a chair which can be controlled through by blinking your eyes or through brain control. And what I'm about to show you now are the studies that we have conducted with children with a disability. What we would like to present is the fact that physical limitation can interfere in the social and cognitive development of a child, because physical limitations do not prevent the child from interacting with the environment. But we have this idea amongst parents and carers, and what happens is that there is this super protection. If the child has a very severe disability, he needs to be helped always. But in that way, this prevents the child to react. This is what we called learned defense. And that prevents him from interacting. So the child does not do anything because he doesn't have a chance to do it. He's not given the opportunity. And he doesn't want to risk doing anything because he feels he's not prepared to do that. And that is one first obstacle, one first barrier that we have to overcome to show that it is possible. And after that, we showed that we started working to see what signals can be used.